class we can discuss on the topic of RS-232C, and now we can discuss on the topic of 8257 DMA controller, where DMA stands for Direct Memory Access. It is designed by Intel to transfer data at the fastest rate. It allows the device to transfer the data directly to or from memory without any interfaces of the CPU. Using a DMA controller, the device requires the CPU to hold its data, addresses and control bus. So the device is free to transfer the data to or from the memory. The DMA data transfer is initiated only after receiving HLDA signal from the CPU. How DMA operations are performed. Following the sequences of operation performed by the DMA, initially when any devices has to send data between the device and the memory, the device has to send DMA request, that is DRQ, to the DMA controller. The DMA controller sends hold request, that is HRQ, to the CPU and waits for the CPU to assert the HLDA. Then the microprocessor tri-states all the data bus, address bus and control bus. The CPU leaves the control over bus and acknowledges the hold request through HLDA signal. Now the CPU is in hold state and the DMA controller has to manage the operations over buses between the CPU, memory and the input-output devices. The features of DMA controller. Here is the list of some prominent features. It has 4 channels which can be used for 4 IO devices. Each channel has 16-bit address and 14-bit counter. Each channel can transfer the data up to 64 kilobyte. Each channel can be programmed independently. Each channel can perform read transfer, write transfer and verify transfer operations. It generates mask signal to the peripheral devices that 128 bytes have been transferred. It requires a single phase clock. Its frequency ranges from 250 Hz to 3 MHz. It operates in 2 modes, master mode and the slave mode. The 8257 DMA controller DRQ0 to DRQ3. These are the 4 individual channels of DMA request inputs which are used by the peripheral devices for using DMA services. When the fixed priority mode is selected, then DRQ0 has the highest priority and DRQ3 has the lowest priority among them. DAC0 to DAC3. These are the active low DMA acknowledge lines which updates the requesting peripheral about the status of their request by the CPU. This line can also act as strobe lines for the requesting devices. D0 to D7. These are bidirectional data lines which are used to interface the system bus with the internal data bus of DMA controller. In the slave mode, it carries command words to 8257 and status words from 8257. In the master mode, these lines are used to send higher byte of the generated address to the latch. This address is further latched using ADSTB signal. IOR. It is an active low bidirectional tri-state input line which is used by the CPU to read the internal registers of 8257 in the slave mode. In the master mode, it is used to read data from the peripheral devices using a memory write cycle. IOW. It is an active low bidirectional tri-state line which is used to load the contents of the data bus to the 8-bit mode register or upper or lower byte of the 16-bit DMA address register or terminal count register. In the master mode, it is used to load the data to the peripheral devices during DMA memory cycle. Whereas the clock, it is a clock frequency signal which is required for the internal operation of 8257. Reset. This signal is used to reset the DMA controller by disabling all the DMA channels. A0 to A3, these are the 4 least significant address line in the slave modes. They act as an input which selects one of the register to be read or written. In the master mode, they are the 4 least significant memory address output lines generated by the 8257. CS chip select. It is an active low chip select line. In the slave mode, it enables the read or write operation to or from the 8257. In master mode, it displays the read or write operation to or from 8257. A4 to A7 is nothing but these are the higher nibble of the lower byte address generated by the DMA in the master mode. Whereas the ready mode, it is an active high synchronous input signal which makes DMA ready by inserting wait states. HRQ. The signal is used to receive the hold request signal from the output devices. In the slave mode, it is connected with the DRQ input line 8257. In master mode, it is connected with hold input of the CPU. HLDA. It is the hold acknowledgement signal which indicates the DMA controller that bus has been granted to the requesting peripheral by the CPU when set to 1. MEMR. It is the low memory ready signal which is used to read the data from the addressed memory location during the DMA read cycles.